Good morning, ladies and gentlemen. Like I said, you are all my children. So good morning, my children. I'm here this morning to talk to you, or this afternoon, to talk to you about how to be a sound researcher. Like I mentioned before the female came in, you can do very beautiful experiments and collect beautiful data. If you don't know how to put it across to your audience, that's the scientific word. You have not started. I've reviewed many journals in my life that the layout, the language gave me so much headache. I'm the type, for instance, who will not just reject your effort. So I will spend extra days. Maybe that's why I have extra gray hairs. I sleep sometimes 3 o'clock, 4 a.m. I will look and think of ways I can recraft the manuscript to be accepted for publication. I hardly reject any manuscript. If the science is good. If the science is not good, it's a different thing. If it is a communication problem, I put in much effort to get it through. So, the essence of me talking to you this morning is to just advise you and give you some hints on what to do, what not to do to be a good researcher when it comes to technical writing. All right? So, like I was telling you, you need a title. Plus minus should not be too long, should not be more than, say, 15 words, if possible. After that, you need an abstract. And is the evolution of the concepts or theories that you have thought about, maybe in the middle of your sleep. So you will now want to put it to practice and see how the society as a whole will benefit from it. Maybe as a result of innovation you have gotten out of the research, the concept, when you go to the lab and do your research, as a result of the innovation you've come out of it, the society will benefit from it at large. For instance, I'm in collaboration with some Indian professors. 2014, I first went to India to see my collaborators, and I suggested we could do this. They are microbiologists. I'm a polymer scientist. So they try to preserve fruits like mango. And I suggested we could add some nanoparticles to the packaging material, the films, which is polymeric. That's where I come in. And by last year when I went there, they have succeeded in getting some cellular nanocrystals into a blend of 2 different polymers and cast a film from it and use it to wrap mango after adding some oil, essential oil and all that. And we found out that now we can prolong the shelf life of mango by at least an extra 1 week before it starts to grow mold. So they are busy patenting it in India right now. So at the end of the day, the idea, the concept will benefit the society at large. So that is why we scientists, yes, we want papers, we want publications, but we think further. How will it help my grandmother in the village, who will buy a box of mango and 3-4 days it will be rotten? So with this type of packaging material, for instance, maybe my grandmother will be able to prolong the shelf life of such fruits. So that is science. And you think and go to the lab and try it and see what you get out of it. It may work, it may not work. Right now I have 2 of them. But I had some Indian postdocs, those who have had PhDs, who wanted to do some research exposure. And we came out with what we call transdermal cellulose scaffold. It's like a bandage, but we've added some things that are not harmful. If you have a cut and you clean your wound, and you put this bandage into your skin, into your wound, it can dissolve into your skin and heal your wound. It's biodegradable, it's biostable, it's non-toxic. We registered a patent on it at TUT here. Our IP office is busy with a pharmaceutical company in Midland to sell the idea to the company so that they can manufacture it. It's like a bandage. You can put it, your little 2-3-year-old child who is running around and cut himself, just clean it and put it, it will dissolve into his skin without harming him. So that is the essence of science. Well, at my age, I really don't need many publications. You do to grow. But these little things that I can do for the society at large, it's more important to me than having hundreds of publications. I've had so much. I don't need it again. Whether I publish or I don't publish, I will not grow again in TUT. I don't want to be head of department. I don't want to be dean. This I told them in 2003 when I was interviewed. I was telling my student at the back now, my head right now was my PhD student. And I'm comfortable with it. Even if it's a B.Tech student who is a staff, who is my head, I'm fine with it. It doesn't bother me. I don't want administration. No, leave me to. So I know what I want, and you go for it. So not all of us must be HODs or deans or whatever. No. I will contribute in my own small way that I can. So, and I want my contribution to be meaningful to the society, and it is through research, which you will do. I hardly go into the lab. You, my postdocs, they go to the lab and do these researches. Recently, the DST, I was nominated, for instance, for a DST award. So they asked for my CV and all that. The associate dean packaged it and sent it to them. The National Science and Innovation Forum also, they contacted me. I packaged my CV and gave it to them. So we are keeping our fingers crossed. Maybe I'll be lucky. Naledi Pando will honor me with a certificate. Who knows? So if you have passion for science, yeah, you will not lose out, definitely. Yes, you may not make big money, but then your hard work over the years will allow you to be recognized as time goes on. So you think about something, and you know this thing, you may come out with it, with something tangible. Try to see how you can experiment it. It's one of the reasons why I left SASO. I had an idea. It has to go through rigorous vetting to the legal days before you can try and see what you get out of it. And it can take months. But here, if I wake up and I think I can do this, I call one of my students, go to the lab and try this. If it works, it works. But there is a bottleneck in SASO. It's one of the reasons why I left, to be honest. And I thought at my age that time, you come in the morning, you sign in, you go out, you sign out, you want to go to the post office during lunch, you sign in, you come. No. I want to do my things the way I want it. That is why I told you I work from home most of the time. I told the dean, you will not see me here if I don't have assignment like this. I live in Silverton and I stay there. You want me? I work at home through email. I have internet. So in a company, you will be restricted one way or the other. If you want your freedom, academic is a beautiful place. The money may not be large, but if you are prudent with what you get, you will live a good and normal life. And you know, SASO is highly polluted. Before I left SASO, my partner was telling me that I was snoring in the night. And I left, came to Pretoria, which is not as polluted. She has never complained of me snoring. So maybe I've bought my good life by leaving SASO. Who knows? If I were still in SASO, maybe I would have had some whatever. So you lose some, maybe you gain some. So you need to have a question that you want to answer, and the question must be meticulously and carefully planned. It should be novel and flawlessly designed and executed. You need a hypothesis or 2-3 hypotheses, and these are more specific predictions about the nature and direction of the relationship between two variables. A strong hypothesis should give you an insight into a research question, which you have defined earlier on, are testable and measurable by the proposed experiments that you intend to use. And you should have it in a logical manner. And normally no more than 3 primary hypotheses. You know, I told you you can have a hypothesis and maybe 2. If you are having 3-4 hypotheses, you are confusing yourself already. So maybe about 2 should be okay. And the proposer that is hypothesis driven is more likely to succeed. But if you are not hypothesizing anything, it will be difficult for you to achieve your goal. And provide a rationale for your hypothesis. Where did they come from and why are they strong? And provide alternative possibilities for the hypothesis that could be tested. Why did you choose the ones you did over others? Each hypothesis must be matched with specific aim. So now we've left the research question, hypothesis, there must be an aim of the work. If you have a good hypothesis, or if you have good hypotheses, they will lead to specific aims. Specific aims are the steps you are going to take to test your hypothesis and what you want to accomplish in the course of the research work. So you need to measure your objectives, and they must be measurable and highly focused. What makes an astute researcher? What are the qualities of a good researcher? There is always a researcher within every individual, even our grandmas in the village. When was it? Was it last year? Sometimes this is my grandmother in Limpopo, this artist. So she's a researcher that went to America. She was in, so she's a strong researcher. So in a way, anybody, any human being, there will be some element of research in you which you need to discover when you come into the labs as a student. The fundamental questions of a good researcher should be intelligence. You must be honest with what you do. Don't more or less fake data. No, it's not good. You must have a curious mind and have the initiative and good enough knowledge of the subject. If your knowledge is not too good, you will struggle. And very good communication skills. Again, for instance, that's where I come in. I'm not bragging or hailing myself for nothing. Science, when it comes to communicating it, I think I'm relatively good in it. In 1985, when I was writing my doctoral work in Glasgow, in Scotland, there were no computers that time. My professor's secretary, who had retired, typed my thesis for me. And he told me, "Hey, Rotimi, and your English is impeccable." Then I said, "Thank you, ma'am." So you need to have good grasp of English. Today, English is the international language for science. Nowhere. China, we try, they will not win. So we will still need English. So you have to have the skills of writing, and I will show you as we move along things in a sentence that should come first. Some people will put it at the end. No. Okay? You say, oh, he tested the mechanical properties and concluded that this is he put comma such as young modulus extension, and all that. The moment you mentioned the mechanical properties, those properties should follow, such as Young modulus. Don't put it at the end. You understand? It will make your work to flow and be more understandable. You need to listen attentively to people that are smarter than you, even your classmates or even your juniors. I learn a lot from my students, a lot. For instance, the old way I did X-ray experiment is different from these days. I had to load my Kodak film into a camera and mount it on the X-ray machine, and the X-ray beam will come, and the sample will be in between. The X-ray beam will come and hit the sample, and that's how we have the diffraction. These days we don't know it. We have X-ray facilities in Building 3. I'm in charge of that lab where we have SCM, and I will come from time to time and teach the students the rudimentary, how it was done some decades ago, before you just press button these days and have the results. It's good you still have an idea of how it was done before it comes to, it becomes a computerized system. And I will teach them how we calculate, for instance, crystal size, which today you press a button and you get the answer. I will teach them how to calculate crystallinity manually from the X-ray diffraction you had gotten. So when I retire, for instance, if there is none of them who is around, coming generation will not know such things. Yeah, I will retire in 5 years' time, and I need to go and rest. Some tips to doing good research. First and foremost, come up with a well-articulated research question, which we have mentioned, by formulating a research hypothesis. Project scope needs to be succinctly evaluated. Sources of possible information in many types and formats should be diligently identified. That's why you have to go to the library and look for information as much as you can. Have a vision and can articulate such vision, and should be able to articulate such vision. Again, you must be passionate. Anything you do like that, I'm passionate about research, and I love to do my research and work hard at communication. Again, communication. Be generous and think beyond their own work to support others. Not just your work alone. Bring other people up. I have a large group of students and postdocs. I bring them in. Some have left. Some is in, there's one in Chile. I've gone to Chile to go and see him. He was a very good Indian scientist. I went to Chile for 2 weeks and saw what he was doing there. We still work together. He is Indian, so the language, he is deficient. He will do his work there and send it to me. I will criticize, we send it for publication. Last week we published a paper, for instance. There's one in South Korea. He spent a year with me and went to South Korea. The same thing, he's Indian. We still work together. I have some who are Indians who are back to India. And anytime I'm in India, I go to see them. They regard me as their father. They are far apart, but I will make sure I'm able to navigate. You know, India is a huge country too, and different states. I make sure I navigate to go and see this, even if it is 2 days or a night with him. Go and see him. How are you doing and all that. That is work together. It's good. And if you work together, you grow together. Before you know it, your CV will be this long and you'll be wanted all over. But if you want to work alone, it can be slightly difficult. Take risks, and you must not be afraid to fail. If need be, sometimes even fail publicly is part of knowledge. Don't be afraid to take risks, but with some common sense. You should not go to the lab and say you are mixing this and this without knowing what possible result before the lab explodes. So you have to be to take such risks with some common sense and find out what will happen if this and this are brought together. Be resilient and be persistent, since patience pays off. More often, if you fail, don't stay down. Yes, this my son, the boxer, Anthony Joshua. Incidentally, his parents are from Nigeria. That's why I call him my son. He beat, what's his name? Recently. This Russian guy knocked him off in round 6. He got up and dealt with him. So don't be afraid if you fall. Have in mind, I will get up. Okay? Be resilient and don't stay down. Don't just stay down. Be diligent and be patient. And if you are in doubt, stop and ask questions from those who know better than you. They could be your junior. It doesn't really matter. Okay? My first daughter was our student here in chemical engineering. She would teach me some things. She did master's here, did PhD here, and I will ask her some questions. One, she's an engineer, I'm not. So there are things, she's back to Nigeria now and in one of the universities there. We still work together also. One of my postdocs was invited recently to write a series of books. He's Indian. He's still with me. His tenure ends in July. And we are planning to write volume 1, 2, 3, 4, 5, 6. The publisher, they want us to write on engineering materials under extreme conditions. We've planned volume 1 now on polymers under extreme high temperatures. We've got about 15 chapters, and I've sent it out to my children all over in Chile, in Korea, in Nigeria, here, that you will write this chapter. You will write this chapter. They will write and send it to me. I will criticize. So this is my Indian postdoc, and I will edit this series of 6 books. So we want to write again also on ceramics. We want to write on metals. I've spoken to my colleagues in metallurgy, for instance, that very soon I will send chapters out to you to write, and we see how to do it. So you have to grow people. Maybe some of you who are metallurgists, Professor Pukwala, will ask you to anchor one chapter. So you learn how to write and be an astute researcher. Be good enough to express your idea. Undoubtedly, you have to be intelligent. Yes, my gogo in Limpopo, she is very, very intelligent. That's why she's able to do what she's doing. So, however, intelligence alone is certainly not enough. You have to be curious and have some initiative in you to back up your intelligence. Be self-examined and be adaptive. Again, adapting yourself to a situation where you can learn from a high school student, if there is the need for you to learn from a high school student. Seek solutions. Don't say, oh, I've tried, I've failed, I won't try again. I was in a meeting just now, Faculty Research Committee. 4 proposals were sent to me to criticize. And it was in PDF. I couldn't edit it. Okay? I had to say, I had to write it on paper, on page so, do this, do that, delete this. And the associate dean told me he was able to edit his own because he's a computer electrical engineer. And I said, okay, please, you will teach me. I left him at the meeting to come here. So I will go back to him now later on for him to teach me how I can edit it. There's a PDF, they were PDF files that were scanned and emailed to us by Adri. They gave me 4 proposals. They just spread it among the members of the committee. So such things I still want to know. How can I edit PDF? I used to edit previously, but on my laptop, I tried, I clicked here, I didn't get the icon or whatever to allow me to edit. So don't be ashamed to learn from anybody. The moment you know it, it's yours, and no Jupiter can take it away from you. So if and when the time comes for you to lead a research team, you have to be diligent, be skillful in your leadership, and encourage collaborative work. It's very important. I have a tall CV is because I like to collaborate with others and bring people up. Like I said, if I don't publish a paper anymore, TUT will not sack me in the next 5 years. But you need it. So if I assign something to you, you do it diligently, then I will be part of it. So I'm still publishing. But mainly my research these days, I like some innovative part of it, not just for publications. All right? To be a good researcher, you must manifest thirst for new information. You must have a sense of things around you. Should reflect or think about things that you come in contact with from time to time. Should be intelligent enough to express your ideas, and must apply a systematic approach in assessing and analyzing solutions. Analyze issues, their meanings, and be able to break down a complex solution into manageable bits. Okay? If you think this is too complex for you, then think about how you can scale it down bit by bit and work on one bit at a time. All right? It is obvious that there is no certain way to teach a young scientist how to become a good researcher. But like I said, I learned most of the things I'm talking to you about on my own through my errors along the years. In the university where I studied in Glasgow, in my time, I don't know whether it happens now, I left Glasgow in 1986, February 1986. I've never been there since. I spent 10 years there. In my time, it wasn't important to publish while you are doing the PhD. Here it is important. So it was after I finished and I went to the university to lecture that I knew if I didn't publish, I would not grow. And I started extracting articles from my PhD work. These skills are perhaps sufficient for a scientist to become a good researcher. However, in order to be excellent, to be consummate, one has to possess a certain gift that can neither be taught nor learned, but is rather in you, intrinsically in you. So this is simply because there is no substitute for talent. You have your inborn in you that you have this zeal to do this. You have this urge to do this. So you need such attitude. Transformation and translation of scientific probes and hypotheses should be a realizable protocol, a must for a modern and serious researcher. Honesty in the interpretation of data and results must be precise. Like I said, don't try to manipulate data to fit a particular thinking. If your data does not go along with other people's reports, state it and think and advance reasons why you think it's like that. People who are in Europe, for instance, who have done some experiments, they got a particular, they have a particular trend between the parameters they are investigating. If you do your own here, maybe during summer, and slightly the ambient temperature is higher than what is obtained in Europe, your result may be slightly different. So you should be able to think of a way or reason why you think your result is different, rather than manipulating it to meet, to look like the ones they have done in Europe. In the relevant field, the researcher must acquire and have excellent knowledge of techniques and measurable tools. We have a number of facilities, like I said, in our lab in Building 3 on the ground floor. Those of us who are material scientists, we should have some reasonable knowledge on these facilities. If you don't, you will not be able to interpret your results. All right? The facilities are there. Now, for instance, you will not just take your samples. There are people who are there who will take your sample and run the experiments for you. So if you need interpretation, you ask them, why is this peak like this? How do I interpret this? If you don't have that knowledge, you will not be able to communicate adequately to the science community. Honesty in the interpretation of data, must be precise. Basic mathematical and statistical principles in order to be able to appreciate and interpret reliably results. If you don't have that mathematical or statistical knowledge, TUT has a statistical office where they will help you to interpret your data if you need statistical analysis. But if you don't know, ask people, ask your supervisor, or anybody you think knows better than you. Now, technical reporting or technical writing. Collection of huge and novel data is as important as reporting meaningfully and convincingly the scientific community. A poorly reported but good data may not fly and may be poorly cited. When you publish, you want your work to be cited. These days we have what we call H-index. You Google my name, for instance, it brings out, they say I have H-index of 10. This one has H-index of 30. So it's the number of citations of your work. So it's important. On the other side, a not very good data can be honestly, truthfully, and convincingly reported to get it read and cited. All right? Yes, the data may not be brilliant, but if you have the ability to report it and convince people, of course, if you convince me and I'm doing similar work, I will cite it. Even though your data may not be that brilliant, but your reporting has allowed me to say, yes, I will buy into it. Then I will cite you. So your H-index also will be growing. Therefore, the art of writing and reporting your work to convince your audience is as important as the collection of data. And remember, journal editors and reviewers often agree that good writing is a sign of clear and logical thinking. Okay? So, if your thinking is clear and logical, you will be able to write to satisfy your targeted audience. And note that most novel and well-constructed study can be rejected if the writing is flawed. I will give you a table of a journal and the percentage rejection due to this thing or this, that, and that. So that is why we have to be mindful of how we write. In science and engineering communities, writing is an essential skill. You need it. Therefore, the ability to communicate clearly and precisely through the written word is as essential. It's an essential skill for every engineering science practitioners. That is why I'm here to talk to you about communicating your results. It is obvious that delayed publications and denial of funding, if you apply to NRA, for instance, because of poorly written manuscripts and grant proposal writings continue to plague researchers. I've applied to NRF a couple of times for funding to buy a facility, and I've not been very successful. There was this young man, he was with us, Professor Peter Olubambi in chemical engineering. He left us in 2015 for UJ. He calls me Dad. He's a very good guy. He has been very successful in funding. So there was a time I thought of buying a thermal conductivity meter in my lab and to apply to the NRF. And the facility, I got quotations, was to cost about a little over R1 million. And I sent it to Peter and said, Peter, let's write the proposal for this facility. And that time I was selfish. I was concentrating on my polymer alone. But Peter is a metallurgist, so he broadened it to include metallurgy as a thermal conductivity meter. We were lucky. We got it. It cost almost 7.5 million. We submitted it in my name, but most of the proposal writing, Peter did it. It's there in our lab there. You, the mechanical engineers and material scientists, you probably will need it one day. So that is, if you don't know, you ask, that we spoke about. Yeah, he's like a son to me, but he has been very successful in proposal writing with the NRF. So I approached him, and the writing was done mainly when he needed, because we had to do it online. I gave him my password and everything to NRF site. So anything he needed something, he would either send me email and say, or call me and say, Daddy, can you give me this? So I will give him. And we were successful, and we got the facilities. We wrote another one last year, was to be about 30-something million, because we wanted to upscale the products we got from that lab to a commercial level stage. We approached Denel. We tried to approach, we didn't succeed, PRASA and these rail agents. One of my master's students came out, for instance, with a tri-alloy of, I've forgotten what they are now, titanium and whatever. And we found out that this material can be used as the trolley on our train instead of the current copper material they use. We got it also patented recently. So we thought PRASA or Transnet, we buy into it. So the conductivity, the corrosion effect, you know, outside with the humidity and everything, these things will corrode quickly. So the corrosion aspect of it, the wear and the properties of this tri-metal alloy are better than the copper wire we are using right now. So that's why we thought we could upscale this and applied for a facility at the NRF that was to cost about 32 million rand. And NRF, they call it strategic equipment funding these days. It has to be a consortium of institutions, not just TUT alone. So I called Peter and we put up the proposal, but we needed other sister institutions to come on board. And other sister institutions, the link person there must update his CV on NRF online. So the guy we made contact with at this company in Ramburg, I've forgotten now, didn't update his CV. They needed a letter from the Vice Chancellor of the cooperating universities that they will partner in this thing. The facility was to be housed here in TUT. I went to Shoshanguve campus to survey and see where we can put it. I wrote a report to the DVC research. But UJ's VC didn't write. Rather, it was the director that wrote initially that they are giving their support, the director of research, that the VCs later will come later on. Wits University didn't write. And VUT in Vanderbilt, they wrote. Lawrence, my VC here, wrote. And beautiful proposal, because people who were to write or update CV on the NRF site did not, we lost it. So it was submitted in my name, but again, Peter did most of the work. He's at UJ now. And NRF wrote to me to say they were sorry because so didn't update his CV because this vice chancellor didn't write. That was our, and it has to be, it's a 3-year cycle. So we can't apply this year. So we will have to wait till another year and pick our members in the consortium carefully, not people who will not update their CV. So you learn, and like I said, Peter is like a son to me, but he came and helped us to put together this proposal. Beautiful. We were supposed to be producing some little things for Denel on their aerospace something to generate money for TUT. But it didn't happen. Important hurdles that may lead to rejection of your manuscript. Significant proportion of papers are poorly constructed and poorly written. And many scientists and engineers have not learned good manuscript writing techniques. Others do not enjoy writing. Yeah, there are some who don't like writing and do not take the time or effort to ensure that the prose is clear and logical. Authors are typically so familiar with the material that it is difficult to step back and view it from the point of view of somebody who is not familiar with science. Yes, you are writing it for scientists, but there are people who may not be even within science. Our work in India now, for instance, I'm not a microbiologist. I was presenting it at Midrand Plastic Federation earlier this year. I was struggling to pronounce these microbiology terms. You understand? So, in such case, I asked my contact in India to prepare the PowerPoint for me. He did, sent it to me, and I went there to present it. Because I'm not a microbiologist, it was difficult for me to communicate all these Staphylococcus and all those bacteria. I couldn't. So I had to focus mainly on the material aspect of it that I know I can explain for our mango to stay longer than it is right now if you use the polymer material to wrap your mangoes. So you may be writing, but consider the audience. Not all of your audience will be an expert in on what you are writing, but they may have interest. Manuscript deficiencies, for instance. A Journal of Emerging Medicine, I got this from them. Causes of rejections of manuscripts. Out of 54 articles evaluated by this journal, only 28 were accepted. Not even up to half. 29 were rejected. And of the 29 rejected, reasons given are ambiguous method, ambiguous results. That's why I said don't manipulate your results. Conclusions not warranted by the data were put in there. I reviewed an article last year for some scientists in Egypt. There were things they didn't do, but they reported. So what am I supposed to do? There's no way I will pass that. That's why I said, even if the science is good and the language is poor, I do extra work on the language and pass it. But if you are reporting the data that I couldn't find in the text, it doesn't make any sense. So these are the percentages and reasons. Even poor referencing, taking 56%, and they rejected the 29 papers. Unclear tables, inadequate study design description, overlay long discussion. You carry on and on and on and on and on, or you may have even to repeat yourself. In technical writing, when you repeat yourself, we call it noise making. You are making noise. Yeah. So if you say something in this section of the manuscript, go to this. You may even rephrase it slightly, but they still make the same thing. You are making noise. Nobody is interested. I won't want you to waste my time reading the same thing. So, overlay long discussion. When you should break and put a full stop, please do. When you should put a comma, please do. All those little things, they matter. Inadequate definition of terms. You just, for instance, put abbreviations without defining it. Don't assume that the community you are talking to will know what the meaning of the abbreviations are. No, don't. Deficiencies in manuscript preparation are more frequent than mistakes in study design and execution. So deficiencies in manuscript preparation, I can say, is even more important than the way you design and execute your experiments. So specific training in manuscript preparation is indicated. So maybe that is why I'm here to talk to you, to give you some knowledge, some experiences, what I had experienced over the years. For 31 years now I've been publishing, and I've had a lot of problems that they will reject it here, but usually reviewers will give reasons where you should attend to. So you attend to such things, you try another journal, and you may be lucky it's accepted. One thing I must reiterate, please don't send same manuscript to 2 or more journals at the same time. Please. Day before yesterday, I didn't sleep on time, and I picked my phone, and a PhD student somewhere said he sent the same manuscript to 2 journals. The point is, you may not even know. These journals may use the same reviewer. And I see your Journal of Polymer Science, Journal of Applied Polymer Science, and the editor send the same journal to me. So please don't do that. In those days, they couldn't find out immediately in my days when I started writing, because it was post that can take 2-3 months in the post before it gets to this. So, but these days, communication has advanced so much that if you try it, they will know. And there is huge penalty for that. They may ban you from publishing in that journal. Okay? So, reporting of experimental and research findings. It is one thing to be a good experimentalist, it's another to be able to report meaningfully. You will see some places I'm repeating myself in this slide. I'm making noise. Yes, I'm making noise. So, to report meaningfully to your audience, they are your consumers. And don't forget, consumers are always right. Just like we go to Pick and Pay, ShopRite, and buy things. If you have problem and you go and complain, of course, the supervisors, the managers should listen to you. The consumers are always right. So your audience, the science communities all over the world that you are reporting to, they are your consumers. So be careful on what you send to them to read. Reporting data materials must be comprehensive enough and understandable by your audience. This is an art on its own, which is very critical to being a good researcher. Beautiful experimental data. Okay, I'm making noise here. So therefore, oral and written preparation and presentations are vitally and crucially important. We were in a meeting this morning, and the associate dean was reporting on a proposal he looked at, and he saw that laboratory were not written in full. They wrote lab. Examination was not written in full. The students wrote exam. No, it is wrong. Write it fully. Laboratory, examination. If you are writing a document, if you are talking to somebody on the street, it's fine. But when you are putting it down, please write it in full. Laboratory, examination, experiment, don't shorten it to exp. No, no, no. Successful preparation of manuscripts. How? Improving productivity. How? There should be adequate and succinct research, accurate and necessary information, logical organization and arrangement of data, clarity of thought, and impeccable writing. Language. Your language has to be good. We, like I was saying, we all are not born English. No, we learn it. But if you need to write it, you have to do it the English way. The English, they write rubbish also. Yes, like I was telling you, the old lady who typed my thesis said, oh, and your language, your English is impeccable. And I said, thank you, ma'am. However, I know I speak good English, but my supervisor also criticized it, so there was no room for it not to be impeccable. It has to be good. Readability, like I said, long sentence, when you should have comma, you didn't put comma, where you should have full stop, you didn't put full stop. It makes your work untidy, and it will be difficult to read and follow. Typical questions to be answered. Who and what are the targeted audience? Is there enough general interest? That if you are sending a manuscript to a journal, for instance, you have to think of which audience you are targeting. One of my my students, actually he is not my student. However, Professor Mukola Stanley, the DVC, is the supervisor. He had to work on some water purification, this student, and he used some polymer material. So Professor Mukola sent him to me. So I'm not officially on board his supervision, but he's all the work he did in my lab. He is to come out with a dual degree from TUT and from Catholic University Leuven in Belgium. He's in Belgium right now defending his PhD work. In 2013, I went to see him in Belgium. Just met the supervisors there in Belgium and how far you are doing, this. He's in Belgium right now defending his PhD thesis. He prepared this material that can treat water, especially in rural places. He concentrated on Limpopo area, for instance, where if we use this material to treat water, my grandmother there in Limpopo should be confident enough to want to use the water. So he prepared the manuscript not too long ago, and he wanted to send it to a journal that deals mainly with water. But one of the mentors is Professor Suprakas at the CSIR. I introduced this young man to Professor Suprakas because I knew he would need their facilities there at the Nano Center in the CSIR. So he sent this manuscript to me, to Suprakas. I corrected, and Suprakas found out that the journal will be better suited in a material science journal, not in water area. So we advised him. So he has sent out the journal now to a material science journal. So you have to choose your audience carefully. Are the descriptions of the procedure adequate if it's an experimental work? Are there enough data information to be reported? If not, maybe you should go back to the lab and gather more data. Are the conclusions justified? Is the quality suitable, and how well written? So you see the previous slide. Conclusions not justified. Where is it? You see, conclusions not warranted. So you have to ask yourself, the conclusions I'm giving out, are they justified? If you are in doubt, stop. Don't send it out. Or go and ask somebody you know, you think knows better than you. They will be able to tell you, yes, this conclusion is good, you can go ahead. No, you still have to work on it before you can infer that, yes, this is the finding. Typical questions to be answered. Clarify a central message before you start writing. Exclude irrelevant experimental data. If you know the data are not too critical in what you want to convey to the outer world, exclude it. Exclude it. Possibility of being misunderstood should be avoided. And put yourself in the position of the reader. And there's this saying, if you want to prick a chick with a needle, try yourself first. So the same thing. Put yourself in the position of the reader. If they send this trash to you to read, will you like it? If you know you will not like it, don't send it to other people. You understand? So put yourself in the position of the reader. Help the reviewers to understand your work and get constructive criticism. Help readers to understand your paper and get more citations. Solicit the opinions of non-experts. They can help also to find out which part of your manuscript is difficult to follow. I criticized I examined a thesis for which university? No, Free State University, Kwakwa, some times ago. The student was a Chinese student, and they sent this thesis to a language expert who, I will imagine, turned it upside down. So I still mentioned it in our meeting this morning that somebody has a BA in English doesn't mean he will be able to criticize a thesis in polymers. No. There are phrases, there are things we use in polymer that he or she has never heard of. So, and to me it was like he turned this poor Chinese thesis upside down. And I wrote my report. It took me a long time to criticize and correct, and I wrote my report and told the university, don't use her again. Yes, I told them, don't use her again, because in fact, the students say, I thank so-so, Mrs. So-so for proofreading. I said, she doesn't deserve the acknowledgement, definitely. That she turned the thesis upside down. Maybe if the Chinese guy, they had sent it to me the way he put it together, it wouldn't have taken me so much time. It was like this guy was translating, I think the name sounded, the language editor, sounded Afrikaans. It's like he was translating Afrikaans to English. And I wrote to Kwakwa, Free State, please don't use her again. She has not done anything good. So, be mindful of your audience and put yourself in the position of your audience. Organization of writing. You plan, you write, you rewrite, you rewrite. If need be, you rewrite and edit. Okay? Don't be don't be tired. So you write, look at it again, rewrite. I sent a student to India about a week and a half ago. He's there right now. He sent me a manuscript that he wants to publish. I sent him to he's working on mango also, doing some deep freezing of mangoes, also for preservation, post-harvest preservation of mango. And he sent me a manuscript that he wants to go and present in Canada at a conference. And I looked at it. I had to scold him. Yesterday, I returned the manuscript to him. I said, you are so careless, you are unmindful, because I have corrected, for instance, his proposal before. All those little things I mentioned, he should by now be able not to make similar mistakes. You put a comma, you don't press the space bar for a space. Does it make sense? You put a full stop, you don't press the space bar before you start another sentence. And you may even start the other sentence with small letter. These little things make your work untidy, and it irritates the reviewer. Like, I got irritated and I scolded in my email to him yesterday. It's like you have not learned anything. You put a bracket, immediately, no space, you open a bracket. Does it make any sense? No. So you write and look at it, rewrite and edit and edit. And these days you write these things, you see, is it red or green? You right click and see the alternative the computer is giving you. No, we are too unbothered. We are not bothered to check and see what those small lines is doing. Our typical questions to be, I'm making noise. We've seen this. Yeah. I'm sure the one I sent to Ben, the Dean, I probably have edited this extra slide. In a research process, writing and editing the paper is the last step in the research. The paper tells the story right from the study inception, data acquisition, statistical analysis, findings, and discussions. The process of writing a manuscript should be analogous to the research process. It requires attention to detail. It takes time, and you need to do revision and revision and rewrite and rewrite and rewrite. Commence writing with the following outline, the way you will section your paper. Outline each segment of the paper by using 1, 2, A, B, C, or 1, 2 Roman figure A, B, C, or the number 1, 2, numerical 1, 2, or small a, b, or an admixture of this. Say 1A, 1B, 1C, and so on. Outline will focus on logical thought and order. It will eliminate unorganized thinking and writing. So if you set out to outline these things like this, 1, so heading, subheading, so, this, so. If you do that, it will help to reduce your illogical thought, your disorder way of presenting your work. It will eliminate unorganized writing and thinking. It will uncover flaws in arguments, and it will make writing easier. Include your draft figures and tables as you go along in the appropriate sections. I have an MTech student. I just finished writing her thesis. She synthesized some polymer hydrogel and loaded some drugs, 1 or 2 drugs, onto the polymer hydrogel. The polymer hydrogel is used as a carrier of this drug to target breast cancer. Just on Monday, I sent this my criticism to her, and I told her she just put figures 1, 2, 3 up to 50 something, but you have chapter 1. Can't you say any figures that you think will come in chapter 1? Figure 1.1, figure 1.2, figure 1.3. Then if you have new figures in chapter 2, figure 2, we will know that the first letter refers to the chapter. But she just put everything going to 55 pages from wherever to wherever. So you need to plan these and put them in order. What happens when a researcher or scientist cannot get beyond outline? We need to go back to the lab and do more research. And cultivating an attitude to review articles may help you. So, you pick an article and you read. You read. For instance, in your literature review, you are not doing any experiment. All you are doing is to review past work. You have to know how to, if you see a sentence in an article you want to refer to, you have to know how to rephrase it to mean the same thing, and you must still reference it. I keep giving examples to my students. I tell them that I saw in an article where somebody said he went to Cape Town by air, and I want to use it. So I have to rephrase it. I can say he flew to Cape Town. They still mean the same thing, but I have not copied and pasted. And I will still reference it. He went to Cape Town by air. It means he flew to Cape Town. Same thing. So when you read and you see a phrase or a sentence you want to put, read to understand and think of how you can recast it to mean the same thing, but you are not copying and pasting. This has worked very well with me and my students. I was telling them at our faculty board meeting this morning that maybe because I'm blessed with the way I can think and understand your sentence and rephrase it differently, that this year alone, for instance, my group, we expect to have about maybe close to 20 book chapters in Elsevier. 4 of them are published already in Wiley. So when they invite me to write book chapters, I distribute it to my children all over the world, in Korea, in Chile, in Nigeria, in South Africa, and they write and send to me. I criticize. If there's something I don't understand, if I can't reach them, I copy and paste in Google to find out. Sometimes, or even some words may be new to me, and I want to find out, is this word gelling with the sentence it's making? I can't reach him on time, I just copy and Google immediately to find out whether the word means what he's saying. So if you are blessed with that, the sky is your limit in output. I estimate this year we will have close to 20 book chapters. 4 are published by Wiley already. 7 in Wiley, yes. 7 by Elsevier. Another 4 by Nova Publishers. My people in India, they sent 2 manuscripts to me. They said Wiley, so I don't know, they must have submitted it. But from here, I know we will publish 7 chapters in a Wiley book this year. And in writing book chapters, all you do is to review past work. And if you know, you read and understand what the researcher is saying, how do you now want to adapt it to what you are writing? How to rephrase and such that it will not be copy and paste. You have to think and think. Coherence in translation of ideas, they should connect. The most convincing ideas in the world, expressed in the most beautiful sentences, will move no one unless those ideas are properly connected with commas, and it should be in the right place. Like I was giving you an example of mechanical properties, young modulus, elongation at break, where these properties should be. Let it be. Don't put it at the end. Okay? Unless readers can move easily from one thought to another, they will surely find something else to read or turn on the television. If you are not connecting properly to interest me, I get bored. Maybe I throw it away and switch on my television. Providing translations between ideas is largely a matter of attitude. You must never assume that your readers know what you know. No. In fact, it is a good idea to assume that to assume not only that your readers need all the information that you have and need to know how you arrived at that point you are at, but also that they are not quite as quick as you are. So don't think everybody will be as smart as you are. No. It may take me more minutes to understand your sentence. There are times if I'm reading my students' thesis, some places have a page, just have a page, can take me more than 30 minutes. I will be probing into his mind or her mind. What does he want to say or she want to say and she's not saying well? And for me to be able to help her recast it. Just have a page that I can spend more than 30 minutes. So you might be able to leap from one side of the stream to another, believe that your readers need some stepping stones, and be sure to replace them in readily accessible and visible spots. So don't assume your reader knows what you are writing. No. A good manuscript layout, again, there must be title, short, like I told you, maybe not more than 15 words. Short, descriptive, and be specific. In our engineering and science community, maybe you will need about 6 keywords from the work. So you say keyword. Then your abstract should be descriptive, be specific, with correct length. Again, maybe not more than half a page. Introduction and background. Short, not too comprehensive. It should be comprehensible. A research question and objective clearly stated, like we said earlier on. Literature cited in comprehensive should be comprehensive and be relevant. You don't just cite just for the fun of it. Experimental materials and methods, descriptive enough to be replicated in other laboratories anywhere in the world. Appropriate statistical analysis if you need it. Layouts, figures, and tables stand on their own. Support conclusions, well constructed. Citations relevant to the topic. Conclusion, it is a must and should highlight the important findings of the work. Like I told you at the beginning, abstract, for instance, you can copy verbatim a sentence or two in your conclusion and put it in abstract. That it is concluded that by adding nanoparticles to this material, the modulus or ultimate strength increased by a factor of so. That's your finding. So, and I told you in abstract, it's what you have done, how you did it, and your findings. So you can copy verbatim a sentence or two from your conclusion and put it in your abstract. It's allowed. That will not sound as if you are making noise. Follow journal guidelines. Okay, references should be clear and logical, and you will have to follow the journal guidelines. Some journals we want you to reference 1, 2, 3. Some we want names, and even those with names, they may want you to put them at the reference segment in alphabetical orders. A, B, name starting with A, B, C, and all that. So you have to be mindful. You first look at a copy of the journal and see their guideline and follow it regularly. Otherwise, they may send it back to you that and you are wasting time. Acknowledgements, if necessary. Whoever contributed helped you to get into where you are, you acknowledge. Glossary of symbols and abbreviations, if necessary, you put it. Appendices. This area, if you have huge amount of figures or tables that we sort of irritate or make a mess in the text, you can put it at the end and say Appendix 1, and you caption it. Appendix 2, you caption it. Appendix 3. And don't forget to caption your tables below. And sorry, your figures below, your tables on top. Results and discussion can be separate. Some journals, they want you to mention results first, then discuss them later. And if you list 4 results, you must discuss them in the sequence of which you have listed them. In some journals, they want you to do both together, results and discussion. Can be separate depending on the format of the journal. Writing, again, should be clear, terse, and logical. And again, follow journal guidelines. Title, again, not too long. I'm making noise again. I won't go into this again. Abstract, okay, maybe between 2 to 200 words. It should concisely state what was done, how it was done, principal results, and their significance. So, like, have a page, at most 3/4 of a page. Abstracts in it should concisely state what was done. Okay. Abstracts in journals should contain the most critical information of the paper. Abstract provides an overview of the paper, highlighting the major findings and conclusions of the work. Almost always, abstracts are the initial decision point by an editor or a reviewer for further consideration. More often, like these book chapters that I said we write, I read the abstract, I read the conclusion. The main work, maybe the way they did this, I can say Zuma and Co. et al. Did this. I will look at their findings and put it. And they came out to be so. All right? Who was it? A student recently was citing reference in abstract. It's almost always never done. Okay? It's almost always never done, not in the abstract. Abstract provides the first impression of the value of the work for reviewers and can influence the outcome of the review process. Once in print, virtually all published abstracts are readily available via electronic literature. Poorly written abstracts with insufficient information or unsupported conclusions will likely diminish the reader's interest in the work. Well-written abstract will present a rationale for why the study was performed. I hope I'm not boring you. Okay, it's time to go, okay. A summary of the methods used in the abstract, like I told you, the data that support the main message and conclusions that do not extend beyond the findings. So don't add conclusions that is not supported by your findings. Again, I'm making noise. Introduction, we've not spoken of introduction. This segment should be short, review the relevant past and present works done in the subject. Some people will want to limit themselves to the last, say, 5-10 years. But sometimes there are good things that Einstein had done centuries ago. If you still have to put it, by all means, if you know it is relevant, please do. Background literature gap and research questions should be covered. Okay? After reading people's work in this introduction section, you should be able to identify what has been done and achieved so far and what you think you can do to push it forward. Okay? Works and authors cited in this segment of the manuscript should be adequately referenced. So like I told you, he flew to Cape Town, he went to Cape Town by air. They mean the same thing. I've rephrased it, I will still have to reference it, that I got it from so. Towards the end, you should give reason why the work is being carried out. All right? That this work is being done with the hope of getting this out or that out. In a review article, like most of these book chapters, to 2009, it was my first time to write a book chapter on the use of polyolefin. Polyolefins are something like polypropylene, polyethylene. The use of polyolefin in automotive. And it was published by Woodhead Publishers. At the end of it all, after the conclusion, I postulated the possible future trends that these polymers will find application in the automotives, maybe in bearings of in a car. So one of the 7 book chapters we published in Elsevier is a follow-up to this, the one I contributed a chapter to in 2009. Incidentally, the editor of this Elsevier is my academic godfather. Incidentally, we went to the same university in Scotland. He finished his PhD 3 or 4 years before I went there to start first year of my BSc. So we still communicate. He migrated to America at MIT. So he was in MIT when he contacted me, and we wrote the first volume. And I contributed a chapter on the use of polyolefins in automotive. So the second edition now, it will be published by Elsevier. He is still the editor. And since I have a large family, my academic children, so I looked at the book itself, and I recognized we could contribute 7 chapters. And I wrote to him. He said, yeah, I should go ahead. So I gave to anchor this chapter. So there was, in this new one, there is still the same use of polyolefins in automotive, but we found more information in literature, newer than it was almost 10 years ago when we published the first volume. So works and authors cited in this segment of the manuscript should be referenced. So I had to reference it, despite the fact that I've written in the first volume, despite the fact that I wrote this chapter, figures that I used then and I still need to use now, I had to write to the publishers because we have willed the IP to the publishers, to Woodhead. Now I had to write to them asking for permission to use the same figures to update the new work. So if there is the need for you to ask for permission to use a particular figure, a particular table, please find out how you will do that. Yeah, you want to ask a question?
Why you ask permission? Because it was your document.
Sorry, it's not my document. It now belongs to Woodhead. We've willed our right to. It's not my document anymore. Okay. Even if it is the work that I did in the lab, and we got this data and plotted the curves and all that, or expose a material to electron microscope, transmission electron microscope, the moment it's been published, you willed your ownership, the right to them. If you still need to use such figures in another thing, you ask for permission. Otherwise, you are self-plagiarizing, which is a crime. Okay? So these things, they are important. Introduction continues. This section of the paper should be brief. Okay, a brief background establishes the contents of the subject matter reported in the paper, a description of the rationale of the study, a summary of the goals of the current study or the hypothesis being tested. Details of materials and methods or findings of the study should not be presented in this introduction, in the introduction section. So after the introduction, there must be materials and methods. It should be a section. Findings is your results, and the way you discuss it should be a different section. So you don't put this in the introduction. Experimenters, materials and methods. This section should contain enough information to allow readers to reproduce your work anywhere in the world adequately. The findings and compare this the study results with other published work. Most often, the method should be detailed to a fault, so that if somebody is to do the work in France or Australia, ladies, please. Okay, I once told the guy who left, if you want to talk, let me see your hand up. Otherwise, I'm the only one to talk. So, most errors by writers include leaving out information such as pH or concentration of a buffer solution if it is in chemical sciences, source and grade of solvent and chemicals. That I got hydrochloric acid from from Sigma Aldrich. I know we have Sigma Aldrich in South Africa, but did I get it in South Africa? You should put it. Yeah.
So, I just want to ask, is it always necessary to include, just like you said all the information has to be in the introduction of how you perform the experiment?
No.
So that someone else.
In the introduction, you will not. Okay. It's a different segment.
But in the document itself,
yeah,
you have to tell us how you got your experiment done,
yeah,
what was done and how you did it. But in most journals, you find that even most of the data they use in getting their graphs are not included. You just find that just a graph. Maybe I'm trying to compare what happened between this and this. I'll just apply the graph, not necessarily how I got the data, for example, or how I worked towards that.
All right. In the experimenter, you should have mentioned you used so for so. So, and this is how you set up this. We have what we call an extruder, for instance, in my discipline, where we mix our polymers, add some nanoparticles and other things, additives, we call it. In the extruder, there's a temperature you will have to set between the barrel of the extruder. There are 3 segments, first, second, third barrel. The temperatures are different in these 3 zones. So you have to mention in zone 1 temperature, and the speed when you are pulling out your molten polymer outside the extruder. You mentioned the revolutions per minute. You are doing that. Those are things you should mention in your experimental section.
Is it applicable to when you're writing a journal or a conference paper, for example, as well? Do you have to include all this as well?
Yeah, it would be good not to put the
most of the papers you can't.
They don't. It's good not to put the readers in doubt. Like I said, if they want to try it elsewhere, they should know how you have done it. You are doing some tensile testing on an instrument, and you have your test length between the jaws of the grips. Then you apply the load and the speed at which you let the upper jaw move from to deform your material until it breaks, maybe. So you have to mention the speed, say 10 millimeters or per second or whatever, so that if I want to try it in wherever in the world, and I want to use your parameters, my results should not be too different from your own. It's good you mention them. Indeed, detail is important. However, do not provide exhaustive descriptions of already published methods. Nonetheless, extensive details are necessary if paper describes a newly developed method. If it's a new method, you need to be explicitly to the point. But if there are same methods you are using, don't go too much in the description of the method. Just pump speed, test length, so temperature, ambient temperature, and so on. Yeah, this is the most important section. Again, your ability to interpret your findings, to make meaning, is very important. For instance, if you do electron microscopy work, and you have your features on your material, maybe some metals, the grains and all that, you should be able to explain why you have a cluster here, where you have some agglomerate here, where you have some fibrils, if it is polymers of a fractured surface. So if you have to, maybe you need to read past work and see how people have interpreted theirs. If you are new and you don't know how to go about it, if your supervisor cannot help you, maybe you need to go and read similar work, and you see this feature, this is how this person interpreted it. Then if it's similar to yours, you can say in your report, in results and discussion, so also has been found similar to what so and so reported. Are you with me? Results and discussion continues. In some journals, they are treated differently. I've mentioned that. So results separate, discussion separate. But in most journals, they are treated together. This section provides a clear description of the experimental findings without interpretation. Okay? And is central to the message of any scientific paper. Information from results should be presented in the order that is most logical to convey the message, not necessarily in order in which the experiments are performed. However, if it is results separate, discussion separate, when you present the results and you are discussing them, it should follow in the order of which you have presented it. Okay? But in the experimental section, it must not necessarily follow. Discussion. Findings are interpreted and placed into context of earlier work. And like I was telling you, you will say it's similar to so reported. Okay? And their significance and impact are explored. The length of discussion should be proportional to the amount of data presented. It is often recommended to start with paragraph stating the strength of the study and its major findings. Results of the primary analysis should be discussed, followed by those of secondary analysis. Order of discussion of results should be parallel, okay, similar to order of the results section. That is, if they are separate. Okay? Postulations about the possible reasons of the findings and the potential benefits of the work are acceptable as long as they are kept within reason. In addition, the limitations of the study and the applicability of the findings should be articulated. And finally, the manuscript should conclude with a paragraph about the significance of the study and its potential impact in the field. Avoid making statements, comments that are not supported by your data. Statistics, again, if you have to use it and you don't know a lot of statistics, seek help. Go to, is it building 2020, am I right? Where the library is. There is a statistician permanently employed by maybe TUT, maybe more than one. Show them your data and ask how to go about analyzing it statistically. If you need statistical softwares, then they will be able to help you. Human and animal subjects. Where human subjects are part of the study, usually journals require statements that review the approval of the study that was obtained from the appropriate ethics committee. Ethics committee is important. I used to be a member of the TUT ethics committee, and okay. So where humans and animals are involved, you need ethics clearance. And your proposals, after it has gone through the department, through the faculty, they go to the ethics committee. It's a big committee, and if they have concern, they will not let you go ahead with your research without attending to their concern. For instance, you want to interview high school students, the reasons why they are not interested in mathematics and physical sciences. You prepare your questionnaire and all that. It's not allowed, you just go there. You have to approach the principal and the guardian of the children before you can do that. It's unethical to do such things. So if in our say biomedical applications, like the transdermal cellulose scaffold that I said can heal your wound, we've not done clinical trial. It has still to be done on rat or whatever before it has to be applied onto a woman, to a human being. So these are ethical angle of such work. So similarly, if animals were used, declaration should be made that local, national, and international standards of treatment were followed. Conclusions. This is a must for all write-ups. You can verbatimly copy and paste 1 or 2 sentences from your abstract into conclusion and vice versa, if need be. It must dwell very briefly on your findings, either experimental or a review work. Acknowledgement. Persons who contributed one way or another but are not part of the authorship, you should acknowledge them. Organizations who contributed one way or another, e.g. funding, use of facilities, you must acknowledge them. I do some work with the Nano Center at the CSIR. My contact there, the director there, Professor Suprakas, we work together a lot. If we write a manuscript and I don't include him, and we use his facilities, I should acknowledge with thanks CSR for providing a particular facility or facilities. But if it's part of the publication, I may not have to do that because his affiliation will be there. Appendices, like I said, if there are large equations, figures, or tables, you put them separately. A glossary of terms and abbreviations, you define them. References, this is a must for all write-ups. Depending on the format of the journal, book, etc., this segment could be in sequential order of appearance in the text, or surnames of authors in numerical order, like I was telling you. A, B, C, names starting with A, then B. So you need to check the journal for the format they want it. In summary, tips for good manuscript writing. Target an appropriate journal. The appropriateness of the message, length, and type of material published in your chosen journal. Impact factor. Yes, this is important. Before I even knew of impact factor, I wasn't bothered as long as I publish and improve my CV. But as I'm growing now, I told my students, don't send any journal, and my postdocs, don't send any journal to manuscript to any journal if its impact factor is less than 2. In my discipline, if you have a journal with an impact factor of 2, it's good. So, but if it is 0.4 or no impact factor at all, to me, I'm just wasting my time. So it's important you check that out before you submit your manuscript. If your impact factor is high, it means the journal is well read, and it will improve your citation, and it's your citation that will fetch you your H index. Yes?
No, I wanted to ask because I really don't know how to calculate that impact factor.
No, I don't. I don't calculate it. The moment I don't know how to calculate it. But you will not know how many people have cited your work. It's the cumulative effect of how many people or how many times your journal has been cited that determines your impact factor. If you are publishing already and the list, I mean, if you Google E.R. Sadiku impact factor, for instance, Google should bring it out for you. It will first show you the number of citations I've received since I've been publishing. I think it's about 2,000 something now. Then my impact factor is around 20 something. I'm hoping I will be able to push it to 30 before I retire, but it's a tall ask. So you look at these things, possibility of publication, journal circulation. Let me go back to the impact factor again. I would rather prefer to have 3-4 journals in a year with average impact factor of about, say, 4 than to have 12 papers with the average impact factor less than 2. You understand? Yes, you will need it to prolong your CV at your level, but I don't need it. So I would rather look for a journal that has good impact factor. I would rather prefer to publish 3 or 4 in a year with average impact factor of about 4 or 5 than publishing 10, 12 with the average impact factor of those 12 less than 2. If need be, obtain institutional approval from if you are employed in TUT, for instance, or you are employed in SASU before you send the publication out. It's not common here in TUT that we obtain institutional approval. Have good collaboration with co-authors. If need be, consult a statistician. Important literature should be reviewed. Be mindful of plagiarism. Make figures and tables easy to understand. Use a published article as a template. Don't copy though, so don't copy and paste. It is necessary to be direct by providing or highlighting points and then provide supporting details. After you have highlighted the points, you have a detail to support what you have highlighted. Keep a consistent order all through the manuscript. For instance, we are careless, we will mix Calibri with area, mix font 10 with font 12. No, it's not good. Start, if you are using area, use area throughout. And if you are using font 12, use font 12 throughout. Not unless the subheadings, if you want to highlight them, you make it maybe font 14 or 16. Okay. Tips continue. Focus on content and stick to topic, and don't dwell or worry too much on where to place the articles, such as A, the article, D is important. Most of my students, they are careless. The article D, they hardly use it. It's important. Present only the information that the audience requires. Language and styles that will make the manuscript clear, use it. Invite a colleague in the subject area or hire an English language editor. I don't like it. In my faculty, Zanele will tell you, I told them in our faculty, none of my students' work must go to a language editor. I can edit good enough. So many of us are not that blessed with good control of English, so they may still need language editor. But like I was saying, not every BA graduate will edit my work. So they may turn it upside down. The phrases and terms we use, they may not even know it. And by the time it comes back to me, no, I don't like it. So normally your thesis, if it is requested, will be sent out to language editor. But I don't allow them to send my students' thesis to language editor. Finally, and very important, don't be discouraged or frustrated when the manuscript is rejected or sent back for revision. Note, acceptance without revision is very uncommon. Respond quickly to revision requests. Remember, giving up is not an option. That is why Anthony Joshua defeated the Russian guy in boxing. He thought, when he was down in round 6, he thought, how am I going to cope? But he was determined, he didn't give up, and he knocked him out in round 11. Okay? Punctuations. This is an important matter because it aids accurate reading as it can affect the meaning of a sentence. For instance, the engines which were in perfect running order had been tested previously. You can recast it that all the engines were in perfect running order and all had been tested. You see? It's two sentences meaning similar things. Okay. However, if the sentence were to be read, the engines which were in perfect running order had been tested previously. The consequence would be that only the engines which were in perfect running order were tested. But that may not be the case. All engines might have been tested, but some were in good running order, some were not. So others had not. The sentence could, of course, be rewritten in order to emphasize what you intend it to mean. Choice of word. The correct choice of word is not just a matter of right word versus the wrong word. Again, the effect on the reader is important, and words can have meanings and overtones. Substantial and excessive might mean the same thing from different points of view. We are very, my students are very, it's common to use, it is much this, it is much that. I will recast it is substantially or considerably than this. The much doesn't sound good enough to my ear. It is much better than this. I will rather say it's considerably better than this. Okay? Overworked words such as basically should be avoided unless they mean precisely what they say. I had a student, a master's student, I think he's at UJ now. In half a page, if he writes, says 4, 5 sentences, at least 3 of them you will see basically. Basically. What do you need basically there for? Ignore the basically and go straight to the word. So, empty words and phrases which give an impression of vagueness, ignore it. So, like rather, quiet, fairly, ignore such words. Sentences like paragraphs should be kept under control. Good style involves a variety in sentence length and in paragraph length. For instance, many technical writers are led into grammatical confusion because their sentences are too long, that by the end the writer and the reader tend to get confused. The most important part of a sentence or paragraph can be lost because it is hidden in a sentence. Short sentence produces a clear, easily read style for factual material. Information which needs to be considered and held in tension with other information is better given in longer sentences which slow the reader down. No reader wants to be brought to a standstill by very long sentences. And don't forget, a one sentence paragraph is not ideal. You just write one sentence. No, you should have at least 2 sentences in a paragraph. Okay? Expandable words in sentences. Avoid as much as possible, avoid things like this. It goes without saying. Needless to say, it is important to note that it may be said that, oh, yeah, why don't you just go straight to your sentence and avoid this? Okay, expandable phrases. Due to the fact that maybe instead of that you can say because of this. All right? An increased number of, maybe if it's possible, use more than. During the time that you can use while, the majority of you can use most, and so on and so forth. For instance, the patient showed no change in symptoms. If it is revised, you can say the patient's symptoms did not change. All right? Put action in a verb. Action inappropriately in a subject. For instance, an increase in heart rate occurred. You can revise it to mean heart rate increased. Okay? Measurement of pH were made with radiometacapillary electrode. You can revise it to mean blood pH was measured with. All right? A particular drug caused a decrease in heart rate when administered in patients. You can revise it to mean when patients were given a particular drug, their heart rate decreased. So, things like that. Use precise words. For instance, in polymer nanocomposite, the addition of small amount of nanoparticles was associated with an increase in elastic modulus. You must have done a tensile testing. You will know how much modulus has increased. So put it there. Say after the addition of 3% by weight nanocomposite, modulus increased by about 60%. Put it there. That one, the reader, it will grasp his attention when he sees this figure. I know, oh, only 3% you added, and you have improved the modulus by 60%. It will be better than the way it was in red. Use simple words. Use men and women, not males and females, except when male and female are used as adjectives, e.g. male donor, male children. All right? Use died, not expired. Yeah. For instance, you are from Nigeria. Okay. When our dictator, Sani Abacha, died, he was a useless man. We went celebrating. I bought drinks for people in the Shabin, so much that day. And papers, rather than using Abacha died, they used expired, still just to rubbish him. So, things like this, when something has died, you use so passed on, don't use expired. All right? Singular and plural, for instance. Data is plural and datum is singular. Sorry. So, stadium, you will see, we will say stadiums, plural. No, is stadia, the plural. Criteria is plural, criterion is singular. Media is plural, medium is fora, forum. Appendix, or appendix is plural. So, all these things, be mindful of them. Short words. Use short words when and where possible, e.g. prior to versus before. So, use before instead of prior to. You see, before is one word. Prior to are two words. So, avoid such things. For instance, following the loading of 3% nanoparticles, the modulus increased by 60%. So, use after. I use following a lot, even though yes. So, after his head injury, Seppo's behavior changed dramatically instead of using following his injury. Use simple words. All heat-stable materials utilized in the manifold of the car were heat-treated prior to use. You can revise it to mean all heat-stable materials used instead of utilized in the manifold, and used before instead of prior to. Use of apostrophes. Apostrophes are not used for plurals of all capital abbreviations or numerals. For instance, in the 1980s, you don't put after you write your 1980, you don't put apostrophes before the S. So, e.g., ECGs, IQs, a woman in her 40s during the 19th, so you don't put apostrophes. Do not forget or omit helping verbs. For instance, the thermoset was prepared and the samples cured in an oven at 100 degrees Celsius for 6 hours. You can say that the thermoset was prepared and the samples were, don't forget the were, before cured. Where is it? And the samples were. You see there's no were. Okay? So this is like a helping verb. So yes, you talk to me and you say the samples were prepared and cured. Fine, but when you write it down, like, don't forget to put and the samples were. Show, reveal, demonstrate. Show indicates something by evidence. The data show that clotting times vary widely. Reveal, make known something previously unknown. Okay? If it is something you have not heard of and you are writing the thesis or your manuscript, you can say the SEM revealed if you know it has not been previously shown. Demonstrate, show by reasoning and experiments. If you will use demonstrate, you must have done something to expose what you are talking about through experimentation. Affect, effect. For instance, affect as a verb is to act on. How excessive drinking of alcohol affects health is still a matter of concern to medical practitioners. Affect as a noun. So we can use affect as a verb, affect as a noun. So emotional state or expression. The asthmatic patient had blunted affect. I'm not sure of this. Effect as a verb is to bring about. He hoped to effect change. With our political madness in South Africa, I'm hoping to effect change. All right, right now. So effect as a noun. He studied the effect of something on something. All right? Can, may, might, when to use it. Very often we say would, could. They are more used for past. Say will instead of say would. Say can instead of could. If it is something present and continuous. Can is the ability to do something. Homogeneous blending, example for instance. Homogeneous blending of two different polymers can be achieved. Can be achieved. Not could be achieved. Where am I? Not could be achieved. Okay? May, there's a possibility, may or may not. So the mechanism may also be the cause of the ozone effect. Might is a smaller possibility. It's much smaller than may. So the research findings might one day lead to a better treatment of wounds of diabetic patients. You know, diabetic patients, diabetics, our wounds don't heal quickly when it has gone advanced. So you may use might, that our research findings might one day, yes?
This presentation will only be given to us at the end of this class.
Okay. Oh, you want this?
To all the students.
Yeah. I think I have your email addresses. Ben wrote to you about this. Okay, I will look for it and just use it and send it to you. So, one day I have a student at Northwest University. He was my MTech student. He worked on diabetics. He loaded 2 different drugs on some polymer substrate, and we used the substrate as a carrier to target diabetic cells. We did some cytotoxicology experiment at UJ, and that time I didn't know we had the facility at the CSIR, so I sent the student to UJ, and the diabetic cells were dying, but we didn't do clinical trial to know the dosage, the concentration of the thing. Examine and evaluate. Patients are examined. Conditions or diseases are evaluated. All right? The doctor evaluated the patient for signs of heart disease. No, the doctor examined the patient for signs of heart disease. Due to or because of. Only use due to when you could substitute caused by. Inherent, the study was halted due to a loss of funding. The student excursion was called off because of loss or lack of funding. The false result was due to an error in statistical analysis. So when to use due to and because of, for instance. Ensure, assure. To make certain, ensure is general. Ensure is a guarantee against loss, like our insurance people who rip us off now and then. Yes, in fact, those are the things the government should look into. I pay more than 6,000 rand on medical health, not for me alone. But before the middle of the year, I go there, they said my something is finished. I have to pay from my pocket. It's rubbish. So assure takes proposition of something. Paragraphs should have unity of content and purpose. In addition, they should also have a psychological effect on the reader. Whenever possible, there should be several paragraphs on a page, with the resulting spaces encouraging reading. The way you space it will encourage me to keep reading. One long block of print is not ideal. A balance between content and ease of reading often has to be kept, but a page which is filled by only one paragraph is best avoided. You know, I told you one paragraph sentence is not ideal. The wrong impression can be created by an non-judicious choice of words, so you have to be careful. The word you use means what you want it to mean at that particular or in that particular sentence. Readers should not be left in doubt at all. Let your work, your write-up be clear to the reader in the meaning of abbreviation, the writer's intention, and the information you are presenting. Brevity, the quality of expressing much in few words, clearness, compactness, and be succinct about it. So concise and exact use of words in writing. Manuscript reports can be long because they may contain a great deal of important information. That is the only reason why a sentence can be long. Otherwise, if you can break such sentence into two. Some may be too long because the writer has explained the same point more than once. Like I said, noise making. Sometimes the writer takes a long time to come to the point. Avoid it. If you take a long time in a sentence to come to the point, I may get bored and we lose interest. So as soon as possible, you can bring the point near at the beginning of the sentence is good. Jargon phrases, avoid it. Impersonal style of writing, also avoid it. For instance, avoid we, I, us, our in your writing. In this work, we did this. If you can, avoid it as much as possible. Rather, you say, in this work, so was done. All right? Clarity. The text of a report needs great care, but the diagrams may be unclear and difficult to use. We were complaining this morning in some proposals that the figures were not good enough. So, graphics packages are helpful, but it is still the responsibility of the writer to ensure that the information is presented in a helpful and unambiguous way. Although a blood letter in a word can frequently be guessed correctly, but blood numbers, figures, 1, 2, 3, you will make a mess of it. If you meant, say, 100, and it looks blood, the 1 before 00 looks like 2, you see the difference, and I read it to be 2. So if it is a word, it's still manageable. You can still think and guess what it means. But if it is numbers, 1, 2, 3, you can be several % off mark. I remember my first book chapter, the publisher came back to me that figures were not good enough, that I should use higher DPI, dots per whatever, in scanning it. So my printer in the office where I scanned the figure, it wasn't good enough. So I had to go to a shop where they have good and better resolution scanning facilities to improve the quality of the figure. Oh, sorry, is there still something I have to talk about? Okay. Most common form of diagram in technical reports, tables can give a great deal of accurate information if they are effectively presented. For instance, what is in this table can be written in a sentence. But if you put it in a table like this, it captures your sense better. Because if you put it in a sentence, particle size range between 150 to 3 micrometer, surface area 2.2. Before you finish the sentence, you have forgotten. But the chances are, if it is in a table like this, you probably will remember tomorrow. Okay? And the captioning, like I told you, tables on top. Where is it? Physical characteristics of this. Graphs, they are used either to show trends or give accurate technical information. All graphs must be clearly labeled and scales identified. If graphs are to be compared, as far as possible, the same scale must be used. Okay? Space, occasionally, diagrams outgrow the pages. So you should find a way of accommodating your graph. Like this, impart strength as a function of tassel loading. This is one of our works some years ago. So captioning down. Here is some rheometry work. This is viscosity, this is storage modulus, and this is loss modulus. So I use this to demonstrate what we call crossover frequency, where storage modulus is equal to loss modulus for my students. So the graph and the figures, you see, red, I label it viscosity. Loss modulus, green. Storage modulus, purple. Am I right? So it should be clear, and the reader should not be in doubt. The book chapter I said I wrote in 2009, I wanted to use this figure. I didn't that time. Now that we are having this figure, that we are having a new version of the book, I decided to use it this time around. And these are parts of automotive where we use polyolefins, polypropylene. You know, I told you the chapter was use of polyolefins in automotive. So all these parts are where you will find these particular polyolefins, plastics. So I used it in this present edition. Maybe before the end of the year, the book will be published. I wrote this chapter because I still have the materials I used. I just updated and put new things in it. In the book, my group, we are contributing 7 chapters, and it's an Elsevier book. Diagram references. All types of figures and tables must be numbered. So, like I was saying, figure 1 point this, blah, 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 you should do that. On completion of the figures, ask the following question. Is it a representation of what you intend? Is it easy to use, read, and understand? Does it look attractive? So don't do mumbo-jumbo thing. Put it the best you can. Like I told you, I had to go to a shop to scan, because the one I use on my small printer in the office, they said it wasn't good enough. So the publisher was considering the audience, not me. So the audience is more important. They are your customers. Summaries, synopsis, and abstract are not quite the same. Summary is often the last part of the of the text. Some journals use them interchangeably too. They call it synopsis, abstract, or summary. So you look at the journal and use the one they want. Okay? Summary gives the whole picture in a small space. You see. Summary should show the essential elements of the whole report. Figures and lists are uncommon in summary. You know, I was telling you that you don't put a reference in summary, in abstract, or synopsis, as some journals we want it. Abstract. On the other hand, abstract is intended to bring together the report to the intended reader. It is to guide readers who might not necessarily consider that a particular report is relevant. So then keywords, you may need to list a few keywords. Manuscript should be checked for all these technical errors, typographical errors, inconsistency, appearance. A reader may be attracted or put off initially by the look of your report. Overcrowdedness, good print, title of page, all these things you have to be mindful of. Guide to good manuscript writing. Audience, again, I think I'm making noise here again. Manuscript should not be too long. References should be correct and in details. Author's title, if you, in your reference. If it is book, you put the year, the publisher, and place. Elsevier publishers, they are all over the place, in the US and all over. If the work was printed in South Africa, Elsevier, you put Elsevier and the year, and the editor. Okay? You say, chapter so, and the title of the chapter from the book title, edited by so, year 2000 and this, publisher so. Okay? Review of manuscript. This is the best opportunity to learn what is necessary for acceptance of the manuscript. It is no time wasted, so don't consider it as if you are wasting time. After you have written it, you have to review it. It is the best exercise to improve the quality of your science. Reviewing constructive comments from the reviewers will Receiving constructive comments from the reviewers will help you in your experimental design and protocols and interpretations of your data. Never do multiple submission. Okay? For instance, simultaneous submission. I Googled this. This is an Elsevier something, and they frown at it. And these are the things. Simultaneous submission or duplicate multiple publication. It's wrong. So don't submit one article to 2 or more journals. Review continues. Extent of novelty of the work. You need to mention it. Technical excellence. Priority, top 5 will probably be published with little or no revision. Top 20, you may have to do some minor revision. Satisfactory, so this is just a scale. A reviewer can rate your submission. Recommendation acceptance, 5% considered after moderate revision, 20%. Oh, okay, even 20% is major revision. So satisfactory, stroke fair, it may be rejected. So, okay, this is what I said. I have it there. This was a manuscript I corrected for somebody. You see, he said nanocomposite plastic films were developed by adding bromide alumina nanoparticles to cortisone. Okay, and I've recast it to mean cortisone nanocomposite plastic films were developed by adding. After adding, the percentages you added should should follow it. Are you with me? Okay, by adding so, then nanoparticles based on cortisone powder weight. So this should come here to cortisone. So then you start a new sentence. The films were cast. Blah, 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 blah. See, this place, the Article D, the application of metallic and non-metallic oxides. He just started with application of the Article D is not used. So the application of metallic and non-metallic oxide nanoparticles and their derivatives in order to modify functional properties should come somewhere here. For their usefulness, okay, for their usefulness should come here. So the linkage between your wordings is important. Otherwise, the reader may lose meaning as you go on. Okay, dried samples, blah, 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 at 22 degrees Celsius, then these are the conditions you operated. Why don't you put the hours immediately after 22 degrees Celsius, as described above? Arising from this, I'm recasting it as a consequence of this. I think he put apostrophes here, reducing product shelf life. So you see, comma. Many of us are guilty about that. The punctuations is important. Concluding remarks: check the manuscript thoroughly for its appearance and make sure that it is pleasing, it is easy to handle, it's interesting, and it is readable. If the technical content is as good as the organization, writing, illustration, and finishing, the report should delight the reader. You can see I put comma here. After finishing, the report should delight the reader and therefore stand a good chance of acceptance. Remember, nothing happens in one day. You prepare this over and over and over. The publication helps and encourages the next. So If it is rejected or criticized negatively, don't be discouraged. Work on the suggestions of the reviewers and try another journal. One publication may open up invaluable opportunities. Very difficult criticism can be addressed if your observation is really correct. If it is not, and difficult criticism, you will not be able to attend to it. Note, a poorly designed research project made worse by unprofessionally written manuscript stands the chance of rejection. Therefore, this can result in a loss or delay in disseminating important and critical information to the science community. Finally, to be a good researcher, one needs to be reasonably intelligent. Okay, I've mentioned those things. You must have passion, you must be smart. So, and your integrity is important. Honesty is important. And you must be a good communicator. The reasonable person adapts himself to the world, whereas the unreasonable persists to adapt the world to himself. I'm quoting Benashaw. Therefore, as a researcher, if your thoughts are wild and seems unreasonable, do not despair. Who knows, those seemingly unreasonable and crazy thoughts and ideas may just be the progress we need to move forward. References. These references are to what I've just spoken to you about this afternoon. Thank you for listening. I hope you will learn something and it will help you in. Thank you.